Hey guys, Mr. Myas is here, and I'm going to talk to you about hypothesis testing. So we're going to look at the steps of a hypothesis test, and I'm only going to talk about two parts of the hypothesis test in this video: how to write our hypothesis and how to state a conclusion. So I'm going to use a one proportion z-test, and so we're just going to look at those first few parts. But I'm going to talk about how do we set up an entire hypothesis test, but only look in this lesson at again, only setting up our hypotheses and then answering our conclusion based on a p-value and an alpha level. So let's take a look at this. Shrink myself down here. All right. So we're looking at a hypothesis test for one sample proportion. So let's suppose that in Mission, Texas, which happens to, according to an article I read or something I read, video I watched, happens to be the percentage of the most overweight population in the United States. So let's suppose in the study the proportion of people that were overweight is 38.5%, and we want to know if there's evidence that the obesity issue is significantly larger than the national average of 35.7%. So we are going to look at comparing our population proportion with our sample proportion. So in this one's a little different than a confidence interval, because in a confidence interval we don't know what the true proportion is and we're not comparing it to anything, we're trying to estimate it. In a hypothesis test, we're trying to see if our sample proportion, how does that compare to a known or a true proportion? Is it larger? Is it smaller? Is it significantly larger or smaller? Or is it just different? So what we're going to do is we're going to do what's called a hypothesis test. And our real goal here is to determine whether or not our sample proportion is strange. Is it strange if in fact the obesity overweight percentage was the same as the national average? Is it strange? Is it would this sample not occur very often? That's what we're looking for. We're looking for that probability. So here's how we do a one sample proportion hypothesis test. So here's the steps. The first step is we're going to write our null and our alternative hypothesis. Our null hypothesis always comes from a base of no change or no difference. So we're really trying to decide, okay, there's no difference in the population proportion and our sample proportion. It's the same. There's no difference. Our alternative hypothesis is either going to be greater than, less than, or not equal to the population proportion. For instance, is the obesity problem in Mission, Texas greater than? Is that proportion greater than what we would normally see in the population? Whereas our null would be that there's no difference in the population and what we see in Mission, Texas. The second thing we're going to do is, because we're using a sampling distribution, we need to create a normal model, and we're going to base this sampling distribution on our null hypothesis. So since we're doing that, we have to identify our conditions for inference. And we've gone over those conditions when we talked about sampling distributions of proportions. I'll go over that in another video when I do the entire hypothesis test. The third thing is where we do all our math, our mechanics. We're going to find our z-score comparing our sample proportion and our population proportion, so our null hypothesis. We're going to find that z-score and then determine the probability that this is going to occur. If in fact the null were true, that probability is called our p-value. Finally, we're going to compare our p-value to what we call an alpha level. And that alpha level basically tells us whether or not we're weird enough, our probability is low enough for us to conclude that our alternative hypothesis is correct, or if we fail to reject our null hypothesis. So our null hypothesis, basically, if you're thinking about a court of law and you think, well, we're innocent until proven guilty. So our did not commit the crime or innocence is our null hypothesis. Whereas our alternative hypothesis is that we are not guilty. They did not commit the crime. We presented evidence so that they are that they did commit the crime, that they are guilty, right? Because they're innocent until proven guilty. So the prosecution's job is to provide evidence that the person on trial is in fact guilty. If we did not provide enough evidence that they are guilty, then we're not accepting that they are innocent. We just say we did not provide enough evidence that they are guilty. So we're not accepting the null. We're just saying we can't reject that it is true, right? Or that it is not true. So basically, here's what we're saying. If we provide enough evidence for the alternative to be true, then we say that we provide enough evidence that the alternative is in fact true. If we did not provide enough evidence, then we say, well, we did not provide enough evidence that the alternative is true, or we would say we would fail to reject the null. We never, ever, ever accept the null hypothesis, okay? We don't accept the null. Okay, so we're going to go and write the hypothesis for our Mission Texas incident. The null and the alternative are always written with the population proportion. So the null is going to be that p is equal to 0.357. So again, there's no change. So it's equal to the national average. Whereas our alternative hypothesis is that p is greater than 0.357. Now on the side, we are going to want to define p. So p in this case, and I don't have this written down here, but p is going to be the proportion of overweight citizens in Mission, Texas. Okay. Again, p is greater than 3.57, and we get this from where it says significantly larger, right? So greater than. Let's take a look at some examples. So is home field advantage real? Well, home field advantage would be real if our proportion of wins was greater than 50%. Because if it's 50%, then the wins and losses are the same. I don't have any special advantage of being at home. So my null hypothesis would be that p is equal to 0.5, and my alternative hypothesis would be that p is greater than 0.5. Let's take a look at another one. 20% of cars of a certain model have needed costly transmission work after being driven between 50,000 and 100,000 miles. The manufacturer hopes that a redesign of the transmission component has solved the problem. So if there was no change, then p would be equal to 0.2. That would be our null hypothesis. If there was a change and the manufacturer hopes that the redesign solves the problem, so we want this to be less than 20% of the cars needing transmission work, so our alternative hypothesis is going to be p is less than 0.2. Now, if the statement had said, is there a difference in transmission work needed, and it didn't really tell me if it was larger or smaller, and I don't really know if I'm looking for it to be greater or less, then I would use a not equal to sign, which does give us different things when we're talking about finding the probability. Okay, so let's talk about getting the conclusion. We're going to get the conclusion when our p-value or our probability after we do all that work is less than our alpha level, because our alpha level tells us whether or not it's rare enough. So what we're looking at is how weird is that p-value? How weird is that sample proportion? So the p-value is the probability that that sample proportion happens if the null hypothesis were true. So if the null hypothesis were true and our p-value was really small, that would tell us that the probability of seeing a sample like we got is very rare. If the null were true, that would mean that the null probably is not true, right? So that's why we reject our null hypothesis and we say, yes, the alternative is correct. So we're going to compare our p-value to our alpha level. This is how we're going to do it. So if the p-value is smaller than the alpha level, so it's lower than the alpha level, then we're going to reject the null and accept the alternative as being correct. If the p-value is larger than the alpha level, so above our alpha level, which the alpha levels are given, by the way, we're going to give you the alpha level to tell you what we're comparing to, then we're going to fail to reject the null hypothesis. We're not ever going to accept the null. All right, so we don't accept the null because the p-value is larger. We didn't provide evidence that the null was true. We're just going to fail to reject. Let's take a look at some examples. Shall we? Yes, we shall. So let's take a look at some examples of how we're going to do this. So we're going to determine the p-value and state the conclusion based on an alpha level that's given. So what we're going to do is we're going to do z is greater than 1.9. So we're going to go to 1.9 here, just right here. And we're going to shade this area because it's greater than. Now I'm just going to put an arrow and say, hey, that's my p-value. The p-value is a shaded area. Now we know how to find the shaded area. We're going to look in our z table. So right now, if you have a z table, look in your z table. I'm not going to go bother and look for it. You should be able to do this already. Since it's greater than, we're going to do 1 minus the value that we find in the z table, which was 0.9713, which gives us a p-value of 0.0. Gives us a p-value of 0.0287. Now we're going to compare that to our alpha level of 0.05. Alpha level is 0.05. Is this going to be greater than or less than that? Well, 0.0287 is less than 0.05, so we're going to reject the null. All right, take a look at another one. Okay, p is less than negative 2.1, so we're going to go here to negative 2.1. We're going to shade in the area down here. That's our p-value. So I'm going to write that like that. I'm going to look that up in my z table, and I'm going to get 0.0179. I'm going to compare that to my alpha level of 0.05 that I get right here, and I'm going to say, hey, that's less than that. So we're going to reject the null. Pretty straightforward, right? Let's take a look at another one. What is this absolute value I see? What does that mean? Well, that comes from when we have a not equal to sign in our alternative hypothesis. What this means is just we're going to go to negative 0.95. And we're going to go to positive 0.95. And we're going to shade up like that and down like this. My p-value is the sum of these shaded regions, okay? My p-value is the sum of these two shaded regions. This is called a two-tailed test, by the way, just because we have two tails, right? So it's the sum of these two shaded regions. So what I'm going to do, these two shaded regions are exactly the same. So I'm going to really look for, I'm just going to find the z less than negative 0.95. Some of you are out there going, now why did I do that? Well, I know that my z table only works in less thans. So it's much easier for me to go to the negative one and just look that up in my z table and multiply that by 2. So that's what I'm going to do. So I look that up and I get 0.1711, which gives me a total p-value of 0.3422. which compared to my alpha level of 0.1 is greater than that. So when my p-value is greater than my alpha level, I'm going to fail to reject the null. All right, that's it on this video. On the next one, I'm going to talk about how we put this all together to do the mechanics and the conditions and do an entire one prop z test, or a hypothesis test for one proportion. All right, catch you guys later.